The paper talks about comparative phylogeography of 4 species of passeriforms from Philippines that reveals complex patterns of colonization and diversification. The study is based on the distribution of 4 species of birds in Philippines. A few hypotheses of colonization and the diversification in the Philippines was stated in the introduction part, which was referenced from previous studies. The first hypothesis was there are 4 possible colonization routes into Philippines. The first route is from present-day Taiwan to Philippines through a submerged land bridge. The second route is from Borneo to Philippines through Palawan. The third route is from Borneo to Philippines through Sulu Archipelago. The fourth route is from Sulawesi to Philippines through a submerged land bridge. The second hypothesis stated that diversification in the Philippines happens between 4 principal island groups. The 4 principal island groups are Greater Luzon, Greater Mindoro, Greater Negros Panay, and Greater Mindanao. These 4 islands was formed and separated during Pleistocene era, which was about 2 million to 11 million years ago. Gene flow was hypothesized to occur before the separation, which results species diversification. To test the hypothesis that was previously stated, patterns of colonization and diversification of the 4 species was determined by analyzing the taxonomic sample, phylogenetic via Bayesian method, extraction of total genomic DNA from the species tissues, as well as comparing with previous research findings. The paper, however, shows an almost completely different result from the hypothesis theory. From their finding, there has been 5 instances of root 2, 8 instances of root 3, and 4 instances of root 4. However, no instances of root 1 colonization was found. It was also hypothesized that birds should largely colonize via route 2, but the paper finds greater support for route 3. As for the diversification, the researchers found that it is intimately tied to colonization routes. Intraspecific phylogeography reveals major island-by-island differentiation rather than differentiation patterns predicted by Pleistocene geography. Once a taxon colonizes the Philippines, gene flow apparently halts among most island groups. This is because, at first, gene flow was possible due to increased glaciation, which would cause sea levels to drop, exposing underwater ridges and shelves that would have connected some group of islands. As the sea level returned to the higher levels, the Pleistocene island group returns to their more fragmented configurations, which halts gene flow. Thus, the researchers inferred that diversification has occurred from island to island only after colonization events.